Graphanicus, I think Darth Olivaricus is in there.
Stay calm, young Padawan.
Hey, so our Arduino has 14 digital and 6 analog ports that we can use. The port numbering starts at 0, as all things should, and while the analog ports are labeled 0 through 5 on the board, it will be important to remember that the Arduino thinks of these as ports 14 through 19 when used as digital ports. Why am I telling you this? I don't know, it's just a fun fact. Get off my ass about it. In our case, we'll need more than 6 analog ports for the photoresistors that we're going to use, and so we need to convert some of the digital ports to analog ports for this project. Why tell you that? Well, so that it makes sense when I tell you that for the LEDs, I'm going to be using as few of these digital ports as logically possible. Initially, I was planning on using 3 digital ports for the LEDs. One for the string in the rear that'll light the wall behind the whole unit. One string for the LEDs that light the rear of the holocrons on either side, and then one string for the 10 crystals. I wanted to group the LEDs this way because I wanted to program them so that they will like dance and work off of each other. So in the end, though, I had to bring the number of digital ports I used down to just 1, which solved one problem but created another, which I'll get to in a minute. But first, I want to talk a little bit about
Melting metal!
My general thoughts about soldering are as follows. Use flux, it's your friend, and makes the solder adhere so much better than going at it dry. The cooler the iron temp, the better for the electronics, but the longer things are going to take. Because of this, I get my iron really hot. Quite frankly, probably too hot. I set mine at 420 and just try to work fast. When soldering chains of things like LEDs, for example, it's smart to put 3 or 5 together and then test. Not only does it remind you of your progress, but it also helps catch bad joints and defective products. I found 2 bad LEDs way earlier than I would have by checking early and often. One I damaged by confusing 2 wires, then screwing up the soldering and desoldering, and the other one was just DOA. So even though this is just 1 out of 100 LEDs gone bad, still going to send it back for that 14.88 cents. Something that people don't talk about often is how tedious putting these electronic parts together can be. You really have to be paying attention when working on soldering or the breadboard. You can catch things on fire if you're not paying attention. In the end, I used 42 LEDs with a positive in, a positive out, a negative in, a negative out, and a data in and a data out. That's 246 soldering joints. If you factor mistakes, that's easily into the 250s. It takes time and attention and a steady hand. For early testing, I ran the power off the Arduino itself to the LEDs, but since that's not the long-term solution, I went ahead and wired up the power supply. This thing is super simple to work with. I lopped off the end of an old computer cable and just stripped the 3 wires inside. The black wire went to line, the white into neutral, and the green into ground. Hopefully you can see it there. To make sure that the output was actually 5 volts, I wired my voltmeter to the output positive and negative terminals and plugged it in. Sure enough, it wasn't actually delivering 5 volts, which could be dangerous for my little LEDs, and if it's too high, dangerous for my Arduino Uno. Lucky for me, there's a little plus screwdriver screwy thing, and I was able to get exactly 5 volts. Once that was done, I ran the output from the power supply to the input row of my breadboard. For a little insurance, I put a capacitor south of the power supply, but north of anything that I would be powering on the power rail of the breadboard. This is a 1000 UF cap. Its job is to store a little electricity and to pass it out if the voltage drops. It keeps everything smooth, and if I accidentally run too much power to this board, it'll take all the damage of the extra electricity and explode, saving my valuable microcontroller and other components. From here on out, if something needs 5 volts, I'll run power and ground to this row. All power goes through here, leaving the Arduino just to worry about the data itself. Between the LEDs and the Arduino, I will place a resistor to help clean up the signal. The Arduino platform runs on a programming language called C++, a language that was released in 1985. It was the first of many languages in the C family to allow the use of objects and classes. It allows the programmer to be more efficient, and a good dev can utilize inheritance, polymorphism, and operator overloading to write very efficient code. C++ isn't aging as well as some would like you to believe, however. I'll show some examples, but C++ handles objects in a really weird way that's often counterintuitive and not very versatile when compared to other modern languages like C#. Full disclosure, I am a full-time C# dev, but that doesn't mean I'm biased against C++. Its biggest advantage over C# is that there are fewer layers of abstraction between me and the CPU I'm writing to. This offers a lot of power with a small footprint, and since these microcontrollers are specifically built with small amounts of CPU and RAM, C++ is a smart choice of language here. While I wouldn't call myself an expert in C++, I would say I know it well, and it is one of the best languages out there. And the best programming languages share a handful of things in common. Knowing those things has been the key to my success as a programmer, and so I offer them here for free, though I should probably write a book. Hey, it's your pal Jordy, the social isolating basement dweller. Have you ever wanted to be successful at a few things while failing hardcore and all the things that normal people are good at? While you were having sex in high school and college, I was learning how to shoot straight to middle management in the IT field. And now I, an overweight male pushing 40, has something to teach you. That's right, you, about how to fail up the long ladder. My book, Void, the Jordy Method, can teach you how to be just like me. For only 3 easy payments of $29.95, you too can have Void, the Jordy Method. In it, you'll learn things like manage a file server under the stairs in your own home, write code that's almost good, but needs a little punching up from other younger males, letting a girl pick you up in junior high and then tying her down with a house, kids, marriage, and a job. Let depression and anxiety get you the weight gain you never knew you wanted. Knowing just enough about electricity to give yourself mild shocks. Dropping random off-topic items into lists. Animal husbandry, or animal magnetism, am I right, ladies? How to keep weirdly inconsequential things a complete secret from your friends while oversharing deeply personal shit that will make those around you uncomfortable. Get super obsessed about a topic and bother all those around you about it for months and months, and then just drop it entirely for no apparent reason. See, I didn't even finish writing the book! Make me realize that selling millions of copies of my book won't make me happy! For the love of everything holy, please buy my book! Patterns and anti-patterns are both great, and they both come and go, but in the end, reusability and portability are going to deliver the best results. Passing an object when you can, act on that object, and pass it back when you need to. Keep your business logic separate than your I/O. When you get stuck, write elaborate, exceedingly detailed questions to Stack Overflow. Those guys are assholes for a reason. Most of the time, you'll figure out the solution to your problem while writing the question. This is the intended behavior. Write thick and meaty comments that basically describe your entire application. When you introduce a new idea to your code, explain it in the comment where the code will live. Your logic will be much more simple and easy to manage that way. Make more smaller chunks of code. That's always better. Developers sometimes talk about or have to react to something called cognitive complexity. That's just a fancy way of saying that your shit method or function is too long. Farm it out and make the methods and classes smaller. I have more, but I'll stop boring you for now. Let's take a look at the actual code for these lights and get something cooking. The LEDs I'm using are Pico clones, so we'll need to install the Pico package in the Arduino code. Pico package. That's fun to say. Did you know that digital ports 0 and 1 are used by the USB when uploading data? Once a sketch is uploaded, they work as normal, but it can sometimes cause confusion for people who leave their Arduinos plugged in all the time. Not cool peeps like me who have moved on to powering our Arduinos with a power supply. Speaking of which... Safety note, unplug your Arduino from the power before plugging the USB in to upload a new sketch. Okay, so what follows is me going through the Arduino code that will be pushed out to the Arduino to power all the lights. If you're not interested in any programming things, you might be able to skip ahead through this. There won't be a lot of jokes or haha funnies. But if you're interested in the code and how this all works, I'm going to try to explain that as quickly as possible. I'll also host all of the Arduino sketches, the files that go onto the Arduino. I'll actually host those on GitHub or on my website. And you'll be able to go and grab those if you want. And I'll put a link down below in the YouTube video. But an Arduino sketch comes in a couple of parts. The first part is just the includes and the declarations. Basically, all you're doing is declaring in C++ all of the things that you're going to use. So here we're declaring that we're going to use the Adafruit NeoPixel library. We're going to start our setup of the LED strip itself. We just used one strand of LEDs, so we only need to declare the one. They're all going to go on the LED pin number 13. There will be 42 LEDs total on the strip. I actually originally had 41 LEDs on the strip, and that was stupid. All numbers should be either 37 or 42. So I added one to the end of the strip and made it 42. The Adafruit library allows for brightnesses up to 255. That number gets complicated for a bunch of different programming reasons, but 255 is a often used number in programming. But that's the brightest that it can be. 0 is obviously off. I've set mine at 150. That's just for now. I can change that anytime I want, but the setup step for now anyway, I've just set at 150. By the way, the higher this number is, the more electricity you consume. So for testing and just running to see if things work, a lower number, just uses less electricity, might make things a little easier. I also declared hard-coded color values for each of the colored crystals that we're using. I went out and color copied all of the crystals just to make sure that they were pretty close to their original WebSafe colors. They actually are. I guess when Disney made these, they made them pretty standard colors. So we have black, for example, would be all off, white would be all on, and these are pretty standard values if you've ever done any programming with colors. The reason I did this is because I want to be able to just say, I want red, I want blue, I want purple, and it'll refer back to these colors. I also declared them as constants. The reason I did that was I don't want them changing by accident. I don't want them changeable. I want them to always be those same colors. From there, I declare my object. In this particular case, my object is called an Adafruit NeoPixel. That's just the object type that Adafruit NeoPixels offer to us, so that's what we just call it. The name for that object, I've just called strip. You could call this anything you want. I just picked strip. And then inside, I have my LED count, which in my case is 42. The pin that I'm using, which is, I guess, 13, as I said earlier. I could change those values up here, and it would change them as they go into the object later. But that's how you build out this object. These last two values here are boilerplate objects. They just kind of come with the setup, and I just kind of included them here. It won't do me any harm to include them, but it might be helpful with some of the object calls later on. I declared a handful of arrays. As you can see here, there's like 5 of them. Since I'm using one long string of LEDs, the idea here is that I need to tell the Arduino where each of those LEDs is. So all arrays start at 0. So the first LED is actually number 0, and the last LED, despite it being number 42, you can't actually see it because my face is over top of it. The last LED on the strip is listed as number 41 here, but it's actually the 42nd one. But they go from 0 to 41. That's 42 LEDs. The Jedi crystals takes the first 5. The Sith crystals takes the next 5. The Sith holocron takes the next 3. The Jedi holocron takes the next 4. And then the rear LEDs for the backside panel take the rest of the LEDs on the strand. One thing of note, C++ has this weird quirk that dot length doesn't actually work like it does in a lot of other languages like C#. So you have to actually declare the length of the array at the time that you're using it, because it's not an attribute that's callable at the time. So unfortunately, this is a frustration of mine, but I had to declare constants that included the length of the array, which in this case is 5, and in this case, for example, is 25. In this case, it's 3. So you'll see why that's important in a second. The next part of an Arduino sketch is the setup. So this is a void method. Void just basically means nothing's going to be returned from it. All Arduino code must include this setup step. In my setup step, it's pretty straightforward at this point. I'm just beginning the strip. I'm initializing this object I created earlier. I am showing the strip, which in this particular case means turn off all of the LEDs. I want, every time the whole thing starts over, I want it to start with it off. And then lastly, we're going to do strip brightness. We just want to declare how bright we want the LEDs to be. I can change that number anytime I want. The next section of an Arduino sketch is the loop. Now, this will run forever until the power gets knocked out. So it'll just keep looping through this over and over and over again. In most cases, I might want to take these 4 method calls, and I'm going to explain this in just one second, and move them into the setup step, because then that would save it from having to loop through again. However, down the road, actually in the next video, I've already done it, we're going to start using the motion detector, and once we start bringing motion detection in, that means all the LEDs will be on a loop. So what I'm doing here is I create a method called setColor, and it's actually down here outside of my loop. And what setColor does is it takes in a color, an array, and the length of that array, and it loops through each pixel, each little LED on the strand in the array, and does the action that I tell it. In this particular case, I'm changing the color, and then I'm showing that change. I'm pushing it out to each of these little LEDs. The first batch is just for the Jedi crystals, and I'm telling that I want it all to be white. I want them all to be white, and I'm passing the array itself and how big the array is. The second one, the Sith crystals, those are also going to be white. I'm going to show you this in just a minute. And that's also 5, and that's this part of this array, the Jedi holocron, the Sith holocron, and then what I'm doing here is I'm spinning the colors of the rear set of LEDs. I'm going to show this in just a second, but I want to spin it the colors white, red, blue, purple. I just kind of randomly pick those. You could pick any color you want, but I'm spinning those colors because for now anyway, I just want to show that I can kind of pass things to and from the Arduino out through a data channel to each individual LED, so that the strand will light up different colors, and then it'll change over time. I'm actually waiting in between each change 1,000 milliseconds. So I send it off to this method, the setColor method, and then I wait 1,000 milliseconds, and then I send it the next color, and then when I get to the bottom here, the loop just starts over. So here in a second, I'm going to show how that works. And that is simply the code for this particular part. It's pretty straightforward. It's pretty easy. At this point, it's going to get way more complicated soon. Okay, so we're going to see how the GoPro works in this scenario. But what I wanted to show really quickly is how exactly we run all of the things from the breadboard, and then I'll show the actual LED lights. So what we have here is just the power in from the power supply. We have our there are 3 wires from the LEDs. This whole row is our power line. So we have a positive and negative for the LEDs. We have a positive and negative for the Arduino itself, which we've only plugged in since we unplugged the USB from the computer. Then we have a data line from the LEDs that goes through our resistor, and then it goes out to the correct pin on our Arduino. I've just set all the LEDs onto the now painted backing plate, and when we turn it on, hopefully we won't start a fire. Not this time. So as you can see here, it starts with the 5 LEDs for the Jedi crystals, the 5 LEDs for the Sith crystals. We then have 3 red LEDs. Those will be behind the Sith holocron, immediately followed, and they're in a triangle shape. That's why there's 3 of them. And then immediately behind the Jedi holocron, there'll be these 4 blue ones. And then the rest of the LEDs on the strand are the ones for the rear of the unit itself, and they'll just change colors and they'll do all kinds of different things. There's actually gonna be a lot of programming that goes into these. For now, I'm just doing this as a test, but I want the background to breathe and react to different sort of inputs. Like when you pull a crystal out, I want them to change the color of that to the color of that crystal and things like that. So this is where we are for right now. All the LEDs are wired up and ready to go.